Today I'm going to be demonstrating the photoelectric effect determining Planck's constant simulation in virtual labs. I'm going to click on the eyeball icon to preview this lab from a student perspective. As before every simulation, we have an introduction slide that includes key concepts, an overview of learning objectives or outcomes for the simulation itself, and some key information before the student begins. On the upper left hand, you can see Introduction and Laboratory Simulation as two tabs that you can click between at any time during the simulation, so this material can always be referenced by the student. I'm going to continue to the laboratory simulation by clicking on the lower right-hand side. Again, we're in instructor mode, viewing from a student perspective, so we do have shortcuts if we want to see what the students will be doing, but not necessarily complete the simulation ourselves. I'll click out of that for now. You can also see, as a lab manual might have in a physical lab, by clicking on methods, what all of the steps through all of the phases will be. You can see that in phase 1, we'll calibrate the equipment, and then in each of the following phases, we'll collect data for wavelength 1, wavelength 2, wavelength 3, etc., before skipping to the end and taking a look at the graphing and the actual calculation of Planck's constant. So on the right-hand side, you can see that we are in phase 1, calibration, and the steps for that are all listed out. So if we are a student, we're entering in, we've never seen this equipment before, clicking show labels is a nice way to get familiar with what you're looking at when you quote unquote walk up to the bench. I will click into the optical filter box, grab that lamp cap to cover the light source, and similarly cover photodiode enclosure with the relevant cap. Now, if I were a student and I were not sure which steps I had already done, if I click go to phase 2, you can see that those first 2 steps will check off and the alert shows which steps have not yet been completed. But those steps weren't automatically checked off as we were doing them, so just backing off a little bit on the hand holding despite giving each step as needed. We'll turn on the power supply and the photoelectric effect apparatus. The simulation automatically zooms in so that we get a better view of the controls. And we want to turn the current range to 10 to the negative 13th. We'll press the phototube signal button to calibration and adjust the calibration knob as indicated in step 7. Okay, finally we'll measure, and that completes calibration. Notice that each of the steps is checked off and student progress is automatically saved with the completion of each phase. So if your simulation assignment is worth 100 points and a student only completes 2 phases, they will get 20 of those 100 points at the due date. We'll actually do some measuring in this phase. We're now in phase 2. We're going to measure the stopping potential at wavelength 1. Following those steps again, click on the photodiode cover, put it away in the box, zoom into the box and notice that these are all labeled. We'll grab the 4mm cap as indicated, put it on the photodiode enclosure, similarly the 117 nanometer cap. Okay, again, we can't proceed unless we complete all of the steps. And we're being prompted now to calculate the frequency and record in the lab data to 2 decimal places. So on the toolbar below the simulation, we'll click into lab data. The student has the ability now to click into that box and is asked to calculate the frequency. So we'll show a couple of ways that some course correction is given by the system. First, if they're off by an order of magnitude and they put in an incorrect number, it indicates to verify your frequency calculation. And similarly, if they enter their data to the wrong number of decimal places against that guidance and against that step, it will ask again to verify. So we'll put in the correct answer and notice that that alert goes away. Now, they can complete the lab with incorrect or incomplete or wrong decimal places data. They do not have to correct it, but I will for the sake of the demonstration. Notice too that here in lab data, some of that information from the introduction slide is available in a pop-up window. So that's something that they are immediately prompted to take a look at, but you can also click back and forth with the introduction slide rather. Okay, so we added that lab data. We can now uncover the light source and take a look again at the photoelectric effect apparatus. We're asked to determine whether there is a photocurrent. Again, we'll go into lab data, and that's movable so that we can note that our observation here is yes. We'll adjust the voltage until the current is 0. Noticing that the illustration of electron movement is changing with the movement of these dials. Okay. So pulling up the lab data again, we'll enter our observation for the stopping potential. All that's left to complete this phase is to zoom out and to cover the light source and to remove the 117 nanometer filter. Okay, so I went through each of the additional phases for each additional wavelength and recorded and calculated the relevant data. So you can see when I pull up the lab data window, that data sheet is complete. For each simulation where it's appropriate, there will be a graphing phase at about this point. Once the data has been collected, students are prompted to select their x-axis and y-axis variables and to create the relevant graph. In this case, for step 5, we're also prompted to show the linear regression so that we can see the line and the equation for that line there. Within the lab data, we're also prompted to do several calculations for the slope, or at least recording for the slope, the y-intercept, and then for Planck's constant, again. That pop-up window with how to calculate Planck's constant provides them with the guidance that they need at the time that they need it. Similarly, once we calculate the work function, we then have the table here where we can assess which element we think we're working with. I'll select cobalt and close the lab window, the lab data window rather. Move on to the next phase. Notice that we want that graph to be saved in the lab report that's available at the very end of the simulation. I forgot to click save. So thank you for the alert. There we go. Graph 1 is now saved and will be available. And that's the Planck's constant simulation. You can see that the lab data is all available here. It's all collected. You can ask students to copy and paste it into an Excel sheet to do more analysis if you'd like. We do have that graph. You can ask students to print to PDF and turn in the report or write up an analysis or a reflection on what they did. And when the lab is complete, the congratulations window will automatically show that a complete grade has been submitted. These are completion-based simulations, so whether a student got exactly the right data or answered any pop-up questions correctly or incorrectly on the first try, they still get the points for completing the lab itself. And that's Planck's constant.